Hello there. We're getting ready for some trig identity memorization. This becomes a huge task for a lot of students out there, so I've got a fun way to do it. But before we get into it, we need to have some basic pre-knowledge. You need to remember your good old SOHCAHTOA, the good old trig functions. I'm going to share this with you. You remember that with that 90-degree triangle, good old right triangle there, you've got sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, tangent is opposite over adjacent. And that's the good old-fashioned SOHCAHTOA. You can see right under where I say SOHCAHTOA, I have this weird choshikao. I kind of joke around and say that sounds like the Asian cousin of SOHCAHTOA. But what that is, choshikao, is the reciprocal functions for sine, cosine, and tangent. So the reciprocal of sine is cosecant, which is the c, and you can see that the reciprocal happened, hypotenuse over opposite, or HO. And then the next one for cosine, the reciprocal of that is secant, and the reciprocal for tangent is really the most easy one, which is cotangent. So always remember that the S and C's do not go with each other, they go with the other letter. That's a good way to remember it. To help you with that. So having that base knowledge, we're going to dive in the next video into trig identities. All right, here we go. We're going to look into the first video here for the magic hexagon for trig identities. So this is for memorizing trig identities. Thanks for watching the pre-knowledge video before this. Here is a hexagon, obviously, a six-sided figure. And you can see there's a big old 1 in the middle. So how in the world is this going to help you with trig identities? Well, here you go. What you do is, if you think back to memorizing the unit circle to where you had the quadrants, the corner up here, this would be in the first quadrant. So you're going to start there. So if you just think, start first quadrant, and then you're going to go counterclockwise, just like a unit circle. Same sort of concept here with the hexagon, except we're not on an XY plane. But anyway, so up in the top here, you can see there's our cosine. So we're actually going in alphabetical order with the trig functions. So we've got cosine, sine, and tangent. It's easy enough. And what's great is coming now through the other 6 points of the hexagon are the very reciprocals that we talked about before. So if you look at the cosine and go straight all the way across through the 1, over here to the other side, you're going to get the secant. And then after that, it's going to be sine going all the way across, so that one should be the cosine. And then, of course, the last one is the cotangent. So that's our magic hexagon. We're going to see how we can get trig identities out of this hexagon. So this is the thing that you want to know how to draw. And then after that, you're able to find a ton of different identities. Thanks. Looking forward to seeing you on the next video. All right, thanks for coming back. Next, we're going to look at this magic hexagon, and we're going to see how it comes into this quotient identities. Each one of these names have been on various teachers' lists of trig identities that you have to learn. So that's why I'm using these concepts. This first one here, this is pretty simple. You just start at one of the functions and you go clockwise or counterclockwise. So for instance, tangent equals sine divided by cosine. That's what this quotient identity is. For those of you that don't remember, way back when you started school, quotient was the answer to division. That's where they get this name. But it is that simple. It's also, cosine equals sine divided by tangent, or tangent equals secant divided by cosecant. You can go anywhere, any direction around this thing. You've got a whole long list of identities. So hopefully this helps you with memorizing. This heck of a lot easier than a big long list to just have this hexagon drawn and it's on there. There you go. Thanks. Look forward to seeing you on the next one. All right, Henry. I'm continuing for you because you're going to get this long video all put together. You probably already saw the first one, and I probably already explained it. But anyway, on to the third one. Here we go. All right, ladies and gentlemen, welcome back. Now that you know the quotient identities and you've seen the magic hexagon, we're going to see the magic hexagon used again for product identities. For product identities, basically what you're going to do is you skip a function. So you take two functions around and then you come back to that one you skipped. The two around it multiply to become the one. So the example here on the left is tangent times cosine equals sine. Also, you can jump across the middle now with the product identities. So tangent times cotangent equals 1. So there you go. That's the product identities. Hopefully this helps you out. And this is becoming a lot easier to build your knowledge of trig identities. Got so many more for you as well. Thanks. Look forward to seeing you on the next one. All right, Henry. There's that one. And hopefully we can do the next one. And you can get these down. With each one of these, if you want to stop the video and work on memorizing, like draw out all of the identities for each one of these lists, especially if you look back at your teacher's list, that'll definitely help you. All right, folks, here we are. We're ready for our next list, or next identity thing here with the magic hexagon. We've got the reciprocal identities. Now, we kind of mentioned this in the pre-knowledge for the magic hexagon, or for trig identities, but this is just kind of showing you it on the magic hexagon. So if you start up in the corner, like sine, and you go straight across through the 1, you've got sine equals 1 divided by cosecant. This also could be put in the quotient category, where we're going around clockwise or counterclockwise. You can also go across and still get the same concept of the number divided by the other number. Thanks again. I look forward to you on the next one. Did not mean to do that. All right, Henry, coming back to it here. Did not mean to shrink that, but you've got this. And then here we go. Here's the next one. All right, ladies and gentlemen, welcome back. Hopefully you're doing really well with these identities. Here is probably the most complex one that I've shown you so far using the magic hexagon. With this one, you can't just start anywhere. You actually have to start, you have to create this like 3 different triangles thing here. That's pretty much the only 3 that technically work. Actually, the only 3 that do work. So that's how you want to look at them. So the way I've taught some students is you start at the top triangle, and that's the first one you look at, which is sine squared plus cosine squared equals 1. That's a Pythagorean identity. That's pretty easy to remember because it's like a squared plus b squared equals c squared. So you kind of think of it that way. And then you go on around to the others, and you can see you start at 1 with this one, then you go to cotangent. So 1 plus cotangent squared equals cosecant squared. By the way, if you're getting confused on where the 1 is and everything, just you can think of it as 1 squared. That way everything's squared, and you don't get confused, because remember 1 squared is just 1. So that makes life easier. And then over on this other one, I know it's kind of cut off here on my video, but you've got tangent squared plus 1 equals secant squared. So there you go. Hopefully that will work out for you, and you'll do well with that. That ends your video, Henry, and I'll have more practice for you. But this is you beginning to memorize those trig identities and really put them in practice. I look forward to seeing you live, and that you let me know that you have got this down. And if you're struggling with it at all, shoot me a text. Let me know ASAP, so we can keep you learning this as in line with the other stuff you're learning, especially now that stuff is still easy in your math class. Thanks.